Hi everyone, welcome to this last IEA Wind Task 43 webinar of the year. My name is Sarah Barber. I lead the Wind Energy Innovation Division at the Eastern Switzerland University of Applied Sciences, and I also co-lead IEA Wind Task 43. And we run a webinar series where we talk about interesting things to do with wind energy digitalization. And this one's going to be serving two purposes. The first one is the launch of the new IEA Wind Task 43 data user group. And secondly, to look at the topic of SCADA events and alarm systems. So those of you who know me know that I just quickly present this slide at the beginning of my meetings. So this has been developed with the Diversity Committee of the European Academy of Wind Energy, and it's just a quick reminder in the meeting that we remind ourselves to use gender-sensitive language, non-violent communication, and practice active listening. If anyone has got any questions about that or comments, then please do that separately. And this slide is actually available for download and use. If you're interested in using it, let me know as well. So this is the agenda. I'm going to quickly do an introduction to IEA Wind Task 43. Then I'm going to pass over to Aris, who is here from EDF Renewables UK and Ireland, who's going to tell you about this user group idea. And then he's going to... You can hear some very loud background noise from somewhere. Okay, it's gone. Aris is then going to pass on to Yuri Marikowski, who's a PhD student in my group, who's going to talk about this topic, SCADA events and alarm systems, and is also going to make a suggestion for a unified model for sharing SCADA error codes. We also, at the end, in the Q&A, we have a Mentimeter quiz, which is quite efficient if we have lots of people listening. So hopefully we'll have time to take part in that and also have some questions. If you've got any questions while we're talking, please write in the chat and I'll try to moderate them. And then in the Q&A session, we can also have some questions while you're speaking if we have time. Is that okay for everyone? Anyone got any questions? Anyone need to know anything before we start? All right, so I'll quickly, for those of you who don't know us, IEA is the International Energy Agency, and there's this thing called the IEA Wind Technology Collaboration Programme, which is an international cooperation of 24 different countries all over the world. And it's about sharing information and research activities to advance wind energy. There's lots and lots of different tasks. You can see on the right here, there's ones related to environmental co-design, to the turbine, the atmosphere, the plant and the grid, social sciences. And ours is just one of these, so ours is number 43. And the idea of Task 43, it's about digitalization. So our vision is to unlock the full value of wind energy through digital transformation. And we want to act as a digital transformation catalyst by driving open collaboration within and beyond the wind community to deliver insights, recommendations, standards, and tools in these three areas of data, culture, and competition. These three areas come actually from a paper, I'll put the link in the chat in a minute, called The Grand Challenges in the Digitalization of Wind Energy, where we kind of reviewed all the state of the art. We did a lot of interviews and surveys. We came to the conclusion that these three areas, the key areas, if you're interested in understanding that and finding out more, please do get in touch. And so Task 43 works around these three areas. We have three working groups in these three areas, but then we also have a use case working group and we have some management activities. And an example of some of our outputs is the wind resource assessment data model. We've published a new ontology portal called Technoportal. We're developing some best practices for publishing ontologies. We're developing best practices for digital twin architecting. We've done a data standards gap analysis. We've also published a really nice paper about knowledge engineering and wind energy. And so that's very quick overview. I'm already a minute late of Task 43. So I suggest if you've got any basic questions about Task 43, please write in the chat or ask me. I'll put the website in the chat as well. So now I'm going to pass over to to Aris. If I think you said you wanted to share your screen.
Thank you very much. Yes, I'll try to do that. Can you see my screen?
Yeah.
Yes.
Yeah. Okay. So yeah, thank you very much for joining from my side as well. I think that I will discuss about two things very quickly. The first one is to introduce the user group, and the second thing is to just discuss a little bit about why we've chosen this subject as the first subject, and then I'll pass over to Yuri, who will do the rest of the presentation. So the data analytics user group has the main purpose of identifying key challenges that are related to operational SCADA-based analysis for operational wind farms. And the aim is to do that by organizing presentation workshops like the one we are here for today, but also get feedback by questions and doing surveys like the one we'll do at the end of this presentation. And then the main goal would be to provide clear and actionable guidelines on the subjects that we will be discussing. So this is the first of the presentations / workshops that we're organizing, and obviously we're part of the Task 43. And if you're interested, please follow the media posts about further workshops on this area. So the main reason we've chosen this particular subject about SCADA alarm codes and events is because we've discussions in the group, we've identified that there is a lot of potential in the actual data that we are seeing, that we believe is a bit unutilized when doing analysis on either fault analysis or looking into performance of the wind farms. Just a quick look on literature. I think it has been identified that 18 to 30% of cost of generation goes into operation and maintenance, which means that it's a significant slice that maybe there is a potential there to be improved. And we believe that by effectively using the alarm codes and events can definitely minimize the cost of operation. Also, the alarm codes between different manufacturers varies significantly, but what we can see is that let's say an average turbine from the common manufacturer will have between 1,000 or 5,000 different alarm codes or alarm types. And every turbine will generate dozens or to hundreds of SCADA events or alarms every single day. So there's a lot of data here that we believe can give a lot of answers to a lot of questions that we're facing on our day-to-day work. So that's me, and I'll pass over to Yuri now, just to continue with the presentation. Yuri, do you want to share your screen, or?
Yes, thank you.
I'll stop sharing then.
Okay, you should be able to see the slides, and let me try to go to the presentation mode. Okay. Someone give me an audible okay that the slides are up, because I cannot see
Yes.
the...
I can see them. Yes.
Awesome. Thank you. Hi everyone, I'm Yuri Markovsky. As Sarah mentioned, I'm a PhD student. Doing my primary work is on making decision support system for digital twins, and we do interact a lot with data when we do these things. And I kind of got also involved in this group with the SCADA group, and I will explain a bit more later on how come. But as Aris mentioned, what we looked into the SCADA data, and we saw that a lot of it is getting generated, but a lot of it is just underutilized. And we try to understand why that is the case. So from what we saw, we identified these 3 main points. Is that one, there is no standardization of events, alarm codes across manufacturers. So SCADA channels will always have their own names, and the codes will be cryptic. And what they say here in brackets, and I don't think we're not really even expecting this to change much in the near future. And the second point, we saw that the standards that are available are not machine readable. So data is not FAIR. For those of you who don't know, FAIR is findable, accessible, interoperable, and reusable. So basically what it means is that effectively there is no automation of or easy automation of analysis of this kind of data. So people have to perform lots of data wrangling, a lot of coordination, a lot of mapping to just make use of the data. And the main thing is, I think that we saw is that just there is no initiative to adopt a common open approach from stakeholders' point of view. Sometimes it's just there is no clear benefit for people to start looking into the standardization or to do something with the current state. So this is a brief slide, not very important, just some existing standards and guidelines that we went through. There's an IEC group, there's an ISO group, but as we said, the main problem with them is that, as first we said, they're not machine readable. We saw that EAC standard, it made an attempt to standardize all the labels, but the adoption is quite limited currently. And we are not quite clear. Maybe it's not comprehensive enough. Maybe it's not usable enough. And what actually ends up happening is that there is a variety of secondary SCADA systems that are put in place, and people develop their own systems for processing SCADA or alarm codes. So there would be companies performing structural health monitoring, predictive maintenance. They would install their own sensors. They would have their own logging, or their own dashboards, and very often just the data that is coming from the native SCADA system from the OEMs is just sitting there, not utilized as much as it could be. And what is seen often from the owner operators is that they have to pay twice at this point. They have to pay once for the wind turbine with the SCADA system installed, and then they have to pay a second time to the company that is installing their another monitoring equipment. There is a variety of additional services that rely on processing events and alarm codes. And there is a whole other standard that actually looks into failure modes, effects, and criticality analysis. But the problem again there is the standard is not machine readable, and the methodologies introduced in FMECA are relying on ad hoc models. So I will explain a bit later on what I mean by these ad hoc models. So we saw, looking at this state, we saw potential areas of improvement. There are mainly 3 potential areas. First one is just in the area of representation of a physical turbine. So there are no common definitions or naming conventions for events. So for example, like what is an event, or what is a warning, or what is an alarm, or what does this thing even mean? Does a warning mean the wind turbine will stop? Does it mean that it's okay, just look into it when you have time? So there is no common definitions on that. It goes even further, is that there are no common models for wind turbine components. So as I said before, for example, MECA relies on identifying, for example, a component on which the failure occurs, but there is no a unique taxonomy of wind turbine components. So this is an example of a taxonomy we published on a Technoportal website, the ontology hosting website that Sarah mentioned before, where we took a study of reliability of wind turbines. It was a big European study called IEA Wind. And when they were performing that studies, they developed a taxonomy of wind turbine components. They actually said, this is how we organize our wind turbine system. And we had to actively find people who were working on this project to get this taxonomy published and in machine readable format, so that people can actually see, oh, that is how you were calling things, how you were defining things. But currently, every time, for example, if MECA analysis is performed, everyone is just developing their own new taxonomy. And then the problem is that the results become non-interoperable. You cannot port the results from one operator to another, because everyone would, they would not agree, for example, that the rotor module is blade hub and the pitch system. Again, reliable wind taxonomy is not the only taxonomy. There is another one system that is called RDSPP, that is probably a bit more known to people here and getting more use. And we are looking into transforming it into a machine readable format as well. So in this condition of like not having developing ad hoc models or not having models leads to another potential area of improvement, where we can have better mapping between event and the physical components of a wind turbine, which is right now is not the case. And another thing that can be improved, obviously, is a consistent approach for accommodating sensors that are unique to a wind turbine. So let's say we have a new some specific model of wind turbine that has unique sensors only to this wind turbine. How do these alarms, events, or how the sensors specific to this wind turbine can be incorporated into a global model where, for example, let's say the IEC standard is not covering the specific type of sensors. For example, some specific acoustic sensors that installed for, which is quite right now quite common for health monitoring companies to install acoustic sensors to get more richer information. So the second potential improvement area, and it's tightly related to the previous topic, but it comes a bit later on and a bit more difficult to tackle, is data management and processing. So here the topics include that there is no an agreed exchange format. So for example, people may be familiar with JSON exchange and JSON schema for validation, HDF5, just plain comma separated values. Some people might know the semantic web technologies, RDF systems, but currently there is not a single unique way to exchange this data. Most common is, yes, Excel tables, so maybe CSV would be like the most common format, but very often it is, when we talk about documentation itself, it's just PDF files. And then storing this data, so again, right now people might store it into some SQL database, but the schema for the database are not clear, they're not defined. So what would be the names of the columns in your database are not agreed upon. Another option would be to have like a graph database with an underlying ontology. People who are more familiar with ontology and knowledge engineering would know what I mean here. But if you want to know more, just read the paper that Sarah has linked in the chat before about knowledge engineering. Then in here in the data management and alarm event processing, another topic is for improvement is the consistent logging behavior. So physical alarm should not start before the stop time of the previous instance with some overlaps to make it easier to process the events, and just the no methodology for aligning alarms, events, and warming with time series. Just the things that make the data not only exchangeable but also reliable and easy to use. And let's say the top of that pinnacle is there can be a methodology to isolate multiple consequential alarms and to perform root cause analysis. So the things that I mentioned before related to failure mode, events, and criticality analysis. So adopting some mathematical logic here, the possibilities again are quite unlimited. We can go with old expert system reasoners, or we can try adapting some new large language models and to perform some grounding and reasoning on the data. But for that to occur, the steps that we described before have to be improved. So the representation problem has to be solved, and the management and processing problem has to be solved. Well, and finally, obviously, I think which is the main focus of this group in general was it would be nice to have open source tools that would help to explore and visualize the data, identifying patterns and anomalies, and just to automate all the analysis in general. So to make this data actually usable as we set out in the very beginning. Here, we don't want to fall into the classic trap of automation. I decided not to bring the XUAD Comic-Con standards because I think everyone has seen it, where we have always N+1 standard. But this one is about sometimes we should not lose the focus on why we are doing actual automation just to free up time, and we should not make it the goal in itself. So in general, how we saw addressing those problems and why those problems arose in the first place is, and that's where I come in a little bit, because I come from another IEA task work group 1.2, which deals with actually information modeling. And the problem is that there is no unified information model. There is no any kind of information, not even unified, just any kind of information model right now that is available for people, that is published, and people can adopt or reuse or improve. So when I talk about information model, just by the way, it can be, and it can, people say, okay, conceptual model, ontology, schema, semantic artifact. I know all of those things mean slightly different things, and in the context, they mean slightly different things, but we can be quite relaxed, and it's essentially say we just need to define, we need a structured representation of concepts, of relationship between those concepts, and we need to specify rules to specify what the data actually means. So some examples of such information models, we are not the first ones to run into this problem. There are a lot of information models that already exist and that have been used and have been very successful. So anytime you need to upload some kind of data to any data hosting portal like Zenodo, you would be probably filling up fields that correspond to a certain schema. So like data site metadata schema or Dublin core schema, which defines things like who is an author, when was data generated, what is the license on data, and stuff like that. If you go shopping or look anything on Google, you will inadvertently be using something that was developed by for e-commerce by a consortium of Google, Yandex, and Microsoft, and I'm not sure some other companies called schema.org. So, and they define many things like organizations, businesses, stuff like that. So here's an example. I put an image from schema.org, which defines the concept of observation and what properties it has. So like it can have things like it's a measure property. So and then you can also specify, okay, what is a measurement method, or what is the error, and so on. And there are other informational models that I'm not going to go into detail, like Eurovogue, basic formal ontology, information modeling framework. Once you get into those, it's quite a rabbit hole, but you can check them out. And some of them are actually described in the paper that we mentioned before. So I think what we need, at least if not even like develop the information model, because we cannot, okay, we are ambitious, but we do realize it's quite difficult to get a community standard going right away. But as a group, while working on the SCADA data, to start thinking about and identifying what are the main concepts that are important and what are the relationships that are important for us to actually use the data in an efficient way. So here I was just throwing some ideas on the whiteboard, and that can be the same way for the work group that starts working on SCADA data. It doesn't have to be using any technology like semantic web or anything, or unified modeling language. You just can start throwing things on the whiteboard and defining, okay, what are important concepts that we need to know. And we need to know, okay, we need to know SCADA system code, and we need to know some kind of like, okay, maintenance or inspection, some kind of action components. And we can, why do we need? Well, because usually, let's say some SCADA system code may require an action. It may require maintenance, inspection, or no action. Some SCADA system code can be related to a certain component, and then we can connect, obviously, those components to already existing models, like I mentioned RDSPP before, or any other kind of model that is used within the organization. But the main thing is that the system is quite flexible, but the core concepts and the relationship should be defined before. And then whether these concepts become classes in a knowledge graph, and the relationships become the edges, or it becomes some database schema, and then it will be used as a basis to create a SQL database. That's I think that's a thing for later. But the main idea I wanted to convey here is that as a group starting to work on the SCADA data system and processing this information and writing some software to process it, it's good to keep these things in mind, write them down, so that it can be later on transformed into some information model that is used by other people and shared. So I think I was quicker than expected, but it is good because that was planned. I really wanted this to be much more interactive and to get much more perspective from the people joining. The next steps is joining Task 43 work groups, or maybe you can, if you want to organize a SCADA alarms expert group or information modeling group specifically for SCADA alarms, then you should probably reach out directly to me or to Sarah or to Aris. And I'll hand it back to Sarah for the Mentimeter, I think.
Yeah, thank you. We've got time for questions, I think, if someone wants to ask some questions. Does anyone want to ask me? Okay, Peter's hand is up.
Yeah, I think it was a really good point about there are taxonomies and you know, the IEC 26 information categories and so on. Surely these are really low-hanging fruit that we can just say, you know, events should be recorded in a way that registers, you know, an information category according to IEC 61400-26, you know, some component identification, if relevant, according to IEA Wind taxonomy or something. That's low-hanging fruit. That would be point one, I would have thought. Point two, I think we can also, a low-hanging fruit is to state some basic requirements. So, for example, the way that events are recorded should be unambiguous. What do I mean by that? There've been, in some instances, I've worked with alarms where the detection and reset time has been part of a single event. In other SCADA data, I've seen where the detection of the alarm and the reset of the alarm have been separate events, recorded as separate events. And if it's a category of alarm where there can be more than one instance active at any one time, then suddenly you have ambiguity. You're like, which one of those instances was reset there? You know, what's going on? So we can at least say, look, this should all be unambiguous. Yeah, it's a basic requirement. So there's some low-hanging fruit, I think. Anyway, that's what I would say.
Yeah, 100%. I don't think it's really credit. I think it's more like a comment, right? Because yeah, I agree 100%. There are a lot of these low-hanging fruits, and that is exactly the reason why I was saying that let's not say, okay, let's make the perfect model right away, but let's see what are pain points already right now between people. Like exactly like, for example, some systems say that this kind of alarm needs to be reset, and some systems say, oh, well, no. And I had exactly the same problem. And maybe like, okay, these should be like different classes so that we know that this belongs to this class of alarms that you have to like actually reset it or it will disappear. So
and it allows you to tie it into contractual requirements. You know, you've got some kind of contractual availability somewhere. You know, the alarms are all, you know, unambiguously labeled with what the information category. You can tie it. You know, it makes life so much easier. I mean, I'm kind of surprised that we're not further ahead on that. But anyway,
and these are exactly the things that should be defined, that should be published and shared so that people can see it, can use it. And I firmly believe that once people see the usefulness of it, they will kind of like adopt it, just because it's such a pain now. It is a bit more difficult than it may seem on the first instance. Just for example, just talking about like time series, and you start talking about all the different ways to store time information, and there is an ISO format and Linux time, and there is
but I think this group's a great idea. You know, that helps us, you know, push this ahead. Yeah, absolutely.
Chris?
Yeah, first of all, I can just agree with Peter there. I wanted to mention there was an effort within Wind Europe. It might still be ongoing around adoption of the IEC-25 and 26 standards. And I think one of the challenges there is that those standards rely a lot on using specific codes, and turbine manufacturers, they don't want to change the codes in an existing system. So I think if you kind of turn it so that they don't need to change anything, but they provide metadata, then that makes it more tractable to do. And I think the next thing I wanted to mention is I think a good question for this group is how we get the turbine manufacturers on board, so that they on projects they can deliver the metadata. And I think there's the -15 standard out now, that Tom, who's been very much involved in Task 43, has led the technical work on, and I think they're a success story in getting the turbine manufacturers involved, and they've realized that they will also benefit from providing the metadata or the data and the metadata in a machine readable formats. I think if it was possible to do that for alarms and events, that would be a massive win for the industry.
Yeah.
I can make a quick comment about getting the manufacturers involved, because I'm just looking at the questions we've asked during the registration form, and I see that there are only 2 people from manufacturers that have actually answered those questions, and it's less than 5% of the people who've joined the call. Which I mean, yeah, just I think I totally agree with what Christian's saying, that we need to get manufacturers really more involved into this discussion, because we will then all benefit from it. Definitely.
Should we move on to the Mentimeter? I think some of you, 4 of you at least, have already started doing the first question. I put the link in the chat, or you can just scan the QR code on your screen with your phone, or you can go to menti.com and put that code in. So if you want to do that, then we can ask the first question. I'll share the screen in a minute once I'm sure that everybody's answered the first question. So the first question is, for which applications do you most often process alarms and events? So I'll wait a little bit for you to all read the question. So we've got 10 people responded. Looks like about the same amount of people as we have in the call. And so we have the highest is performance analysis. I think it was multiple answer anyway. I think there's more answers than there are people. So performance analysis is the highest, followed by failure root cause analysis, followed by analysing operational states. Aris, do you want me to just move on to all the questions so that we have time to finish, or do you want me to do you want people to say something about their answers, or how do you want me to do
it? We could go through them, I would say, but yeah, open also.
Oh yeah, maybe let's go through them all, and then at the end, if we've got time, we can ask people if they've got anything particular to say. So you should be able to see the second question now. So the second question is, which are your most frustrating pain points? So it takes a while to read them, I think. Okay, so we have understanding the purpose of each alarm code, inconsistent alarm event log formats across multiple, associating each alarm code to a physical turbine component, and aligning alarms and events with 10-minute times and time series data. Okay, that's so good to know. And then the next question is, which tools do you use to analyze alarms and events? So either the OEM SCADA tools, third-party SCADA tools, or platforms, like spreadsheets, custom developed software, open source software, such as OpenOA or other open source software, or other. It's interesting. Quite a lot of you use custom developed software. None of you use the OEM SCADA.
I mean, it's not surprising, because
yeah,
all the models are different, so you kind of have to write your own code each time you want to automate anything. So
yeah, there are probably people who only work with one OEM type. But anyway, does the person who uses other open source software maybe want to say what that is? I'll write it down. Actually, maybe that's the next question. Let me just see. No, it's not the next question. And then, which standards, guidelines, or frameworks do you rely on for alarm event analysis, if any? So the ISO 16079-1 or the IEC 61400, 25.2 or 6, or none, or other? Mainly none. And maybe we could have some inputs as to why. like the people who wrote none, it's just easier to make up your own thing that works for what you're doing. Or what are the reasons? Anyone want to say anything?
Or the system is just not conforming to the standard, so you can it's not useful to you.
Yeah.
I think maybe different people can only following the manuals from the OEMs, right? That's kind of inconsistent already. So
yeah, and I think it ties in with the previous question or the previous profile of people writing their own custom software. So once you start doing it for yourself, then it's a self-contained environment.
Well, does anyone who answered that question actually want to confirm or dispute those assumptions? Okay. And then I think we asked this question in the registration anyway, didn't we? But anyway, what proportion of project time is typically spent on data wrangling rather than on extracting actionable insights? What percent? This is good. This is providing me good inputs for the launch of the We Do Wind ecosystem, which I'm going to tell you about in a minute anyway, where I'm saying, do you spend 80% of your time wrangling data? Lots of people still do. How much time would you be interested in investing looking into information models for wind energy? So basically, continuing this conversation, actually working on developing the suggestion from Yuri or another one. So 0 hours, 1 hour per week, 1 hour per month, 1 hour per 2 months. I added more, by the way, Aris, to yours, because I thought maybe there's some people who will be prepared to offer 2 hours per week. Okay, so there's a significant number of people who, well, one person put more. Was that Yuri? Or Des? So nobody put 0, which is great. So one person has them now, just because I said that. Looks like quite a lot of people are willing to or interested in investing up to an hour a week, or possibly more. So that's really great. I'm going to tell you about how to do that in a second. In fact, that's the end. So I've got a couple of slides where I want to explain to you how we can continue this conversation.
Sarah, sorry. Before you continue, there was a question in the during the registration form that I was thinking might be a little bit relevant to that. There was a question about, do you have access to SCADA data from the field already? And I was thinking, Sarah, that you've been you might be able to give some answer on that as part of the task 43. I think we've gathered some information about open data there under the public domain. Am I right on that?
Yeah, I can include that in my presentation. I'm just looking for that question actually in the registration. What was the question?
Do you have access to some SCADA data from the field already? It's the last, in the questionnaire, it's at the bottom of it.
Can't see that question. You see my screen?
It was at the bottom, the 3 responses.
Yeah.
So that might be comments from people who answered.
Oh, sorry, I understand. Sorry, I thought you were saying, Iris, that you asked that question. You're saying that someone else.
No.
Okay, I understand. Yeah. So let me. So what I can tell you about quickly. Oh, I've seen a question in the chat. Will you share the survey results? They're important. Yeah, I mean, we publish anyway this recording. We're currently kind of thinking. we've had a few surveys like this before in our webinars where the results are really interesting. Also about digital twin architectures and stuff. And I think we're having internal discussions about how to, because the main point of Task 43 is to develop some sort of best practices or guidelines or something. So, I mean, I was thinking even the results of some of these surveys are like really interesting information. So I think in short, yes, but we're not really quite sure exactly how at the moment. So getting on to the question about not what to get involved, but how to get involved. Strange. So everyone who's registered today is going to get an invitation to sign up for our new We Do Wind open innovation ecosystem in January. And We Do Wind, it's transforming into, if some of you know it, it was originally meant to try to improve data sharing by this idea of challenges. So it's like a load of online continuously running hackathons where all the data and the documentation gets stored in the same place. But we're actually expanding that to a larger community. And so we've got a nice digital platform where you can see the different communities and the different spaces and stuff. And this whole community consists of like these four green sub-communities. So we have an information modeling community where it's all people trying to develop this type of information models like this SCADA alarm code ones we're talking about, but we've also got other ones already in there. And also just sharing knowledge about the topic. And then we have an open source data and code community where we have people publishing code and data, but also sharing guidelines or insights about how to do that in a more effective way. And then we have this knowledge and data sharing community, which is the previous We Do Wind challenges. So in this community, we have a load of companies or organizations who are providing open data, and people come and solve challenges for the companies based on that data. And the final one is the data and code users community, which is where this community that we're trying to build up now would come into it. And so we have these four communities inside the platform, but we also have different portals. So we have the schema and the ontology publishing portal, so the ontology publishing portal is just the techno portal. But we want to develop open code and open data portal. They don't exist yet. It obviously requires quite a lot of infrastructure and platform building to actually have a proper wind energy central data portal, but something we're working on. We also want to have a jobs portal because we think people will take part in this community because they want to find jobs or find people for jobs. I don't know if you know Kaggle, but Kaggle's main business model is recruiting. And so in the information modeling community, we're going to have these different working groups. So we're going to have Task 43 groups in there, which you can only take part in if you're signed up for Task 43, but we're going to have other groups in there as well. So this example, if we did start a group doing SCADA alarms specifically, then that would be like a public group inside there where you can then document and see all the developments and talk to people. And then the open source data and code community would have, for example, we have a separate community, the RDA, Research Data Alliance group, which is trying to improve the fairness of data. Yuri mentioned the word fair before. We have a specific group looking into analysing different data sets and making recommendations. And then we have a Task 43 open source group as well, where a number of people are trying to come together to develop guidelines for publishing open source code. And then the challenges community, which I mentioned, we currently have 4 challenges running with different data sets available in there. And then this data user group would be in here. It's not here yet. This is what we're working on the next couple of weeks. And so, yeah, you'll receive an invitation for that as soon as it's set up, and you can then probably join other subgroups in the ecosystem. In the meantime, feel free to contact any of us. Just on Aris's question about access to data, so we are planning. So as I was saying, this open data portal doesn't exist yet. But what we're actually planning to do is just to make a list of data sets or other data platforms that we've come across within We Do Wind. So for example, now this is the actual live page. For example, now you go to some different We Do Wind challenges. For example, this is an old one from a Swiss company who submitted, so contributed some SCADA data, and the data is, I'll see it right now actually. I think the data is should be inside there somewhere in the future. Let me just go to a different one because I think for some reason that data is missing. But we have like a challenge description, we have a discussion, we have access to the data set, we have people's solutions that they've submitted. And so it is possible to actually go through these spaces, they're public spaces, and see different data sets. But what we're also going to do is we're going to have a summary of those data sets that we know about, but it's not going to be a dynamic thing yet. So it's not going to be dynamically updating. It's just going to be us putting some lists in. But in the future, we want to have something which is centralizing all the available open data sets. Is that answering the question well enough for now, Aris?
I hope so. I don't know who asked the question, so maybe. But also, Chris has posted a URL to.
That's true.
43. Yeah.
Yeah. So within, I can also show you within I'm currently building it, but we're saying the portal doesn't exist yet, but we've got lists of various resources. So that one of the things that thank you, Chris, for putting that in the chat. That one of the things he did put in was that we've actually in task 43 like made a non-dynamic static list of different available data sets. And so that does link to there as well. Yeah, thank you. Yeah, so I guess, does anybody have any questions about the whole topic to any of us, about getting involved or about the technical details or about something to do with the Mentimeter questions we asked? Anyone want to ask or say anything in the chat or by speaking?
I'm just wondering, Sarah, if people on the call think we've missed some topic or there's some other low-hanging fruit along the lines that Peter mentioned earlier, or high priority pain points, just to see if we're getting off on the right foot here.
I would say I used to be at Greenlight before, which is one of the second level or third layer SCADA systems, and those companies that are working like that are having a lot of information. They have a lot of insight into how the different OEMs and data sources look like. So if we could get them on board also, that would be really, really good. I see at least me and another colleague from Greenlight is in this call. So we've been working with this for a long time, but any of the other type of companies there that's also out on the market will have a lot of knowledge on this specific topic and also how they have worked to standardize it in their systems.
Do you have any ideas about actively getting them on board? How we could get them on board?
Well, I guess for Green by Power Factors, me and Chris has some contacts, but for some of the other companies, I'm not really sure.
Yeah, just word of mouth or LinkedIn or stuff like that. But it's quite difficult to do it like that. Like, I mean, we've got quite a lot of experience with trying to do that in different areas, and I think people knowing about it and telling their colleagues or their ex-colleagues that it's a good thing seems to be one of the most effective ways of doing it. But yeah.
And Christopher, is there any interest or momentum around, say, providing APIs into the various third-party platforms, or is that so to get at the interoperability aspect of it, or is that something that's still quite young in its life cycle?
I would not say that most of these companies do have some well-developed APIs already. Might be more a question on how to share and what to share and IP discussions maybe.
Okay.
But yeah, so I think that might be the tricky part, because there are also private companies that are actually, this is one of the selling points, that they have done this for other companies. So.
Yeah.
I mean, that we get that reaction a lot. Like the companies make their money by having the, you know, knowing all the secrets of all the other companies, and if it's all open, then they don't want to. They're going to lose their business model. But that's, I don't really think that's a long-term efficient strategy for the wind energy sector. But yeah, I understand.
At the same time, I mean, these companies are struggling with the exact same questions that we have been discussing here. I mean, if you're an asset manager with access to 20 different OEMs SCADA systems, you have the same problem as these third-party providers to do this work. I mean, I've been juggling alarm lists for 8 years, and it's really, really difficult to sometimes find good ways to use them. So, I mean, I would say even those companies would be interested in actually trying to find good standards and ease of work to everyone.
Theoretically, hopefully. Chris, you want me to say something?
Yeah, I just wanted to add that I think maybe we as a group, we could look at the kind of the challenges and the value to those key stakeholders and see like what the solution would need to look like that adds value to the people that we need to get involved without kind of compromising the things that are red line for them. For the manufacturers, of course, there's there will be IP concerns. But I think even for a model where they say we give away some of the metadata, but some of the metadata is too sensitive and we don't want to share that, and at least I think we've come some way.
Yeah, I mean, I think it's small steps, right? So we can make something at least to demonstrate. I mean, we get back to this vicious cycle of digitalization, which I've talked about 10 times this week already. If you can make one small step without having them on board in order to demonstrate they could gain, and then they might start with some less sensitive data, and then it's kind of a process. So yeah, let's try to make the first step of this process, I guess.
Yeah, and I mean, they already share a lot of data, and I think, you know, they wouldn't have anything against sharing that data in a standard machine readable format. But if we start asking for a lot of metadata that they don't already share, then there might be some sensitive areas where they say, hey, this is giving away too much of our IP, and then, but I guess the information model doesn't rely on that. The people who provide the data, they can decide how much what they provide and what they don't provide.
Yeah, I mean, the other thing is that the working group doesn't have to be public, right? So then we know about this from other type, like Tim Wind and stuff. There are groups where people do provide metadata or more information than they would do, and it's a closed space, or they even pay to whatever. There's some sort of closed group, and that's also possible, and it's also the idea of this ecosystem that some of the groups are closed, so that's definitely also a possibility. I see it's 4 o'clock on the dot, so let's close from here. We'll be in touch with everybody in the next couple of days with the recording and on the website, but then sometime in January let's sign up to take part in this group, and let's do something actively. So yeah, thanks everybody, and especially to Aris and Yuri for the great preparation of these very complex topics and very clearly presented, I would say. So thank you, and yeah, thank you to you all for coming, and hopefully we'll see you all soon.
Thank you very much.
Thank you.
Thank you.
Okay.
Bye.
Thank you.
Bye.
Thank you. Bye.
Bye bye.